What we are doing here is enabling our agent or harness to access data that is available outside of the LLM and something that is specific to our own project. In this case, it's going to be a SQLite database. When you use an agent or a harness, let's say Claude Code or ChatGPT or anything that connects to an LLM, all the data and the conversation between you and the LLM is handled by the harness. If you have data in a database and you want to make use of it, you need something that is able to expose that in a way that is safe and also in a way that is understandable by the harness. So that's where our MCP server comes in. The MCP server is able to create a connection between an external source or resource, in this case our database, and your agent and harness. If it is able to set up an MCP client, that client would be then connected to our MCP server, and that connection can happen via standard input-output or HTTP. In our example, we are going to do HTTP to allow connections between the MCP server and the database. So let's take a look at that. So in this project, I have a simple database that represents an e-commerce with a users table, products, orders, order items. It is non-relevant for our example. I just wanted to show you what we have as a setup. In the package.json, we have a few utilities for generating migrations, linting, formatting, type check. In the dependencies, we have Zod, Drizzle, SQLite, and the Model Context Protocol official packages for implementations of the Node.js middleware, and a server package. All right, we import MCP server from Model Context Protocol and initialize a new instance of a server, and then we pass it on to the MCP handler, which then goes to the node handler. And finally, we started as the HTTP server on port 3000. At this point, I can go and try start it, but the MCP server is not exposing any kind of tools. And that's what we're going to enable now. So up here in SRC, I will create a new file called tools. What I want to do is have a function that keeps track of my tools. So right here in my factory function, I will do register tools and pass the server to it. Now from here we can start creating tools and passing the server along. So each tool is capable to register the description and they are exposed by the server. The first one that I want to create is list tables, and in list tables, let's say it's going to need the server and also the tables from my table schema. Now I can go to my SRC folder, create tools, and now a tool called list tables. And here's the main thing that we need to look at. Register tables takes the MCP server, the tables, and from the MCP server, we do register tool. We give the tool a name, we add a description, and an input schema. This is possibly the most important part of the registration of tools for MCPs. With the correct description, we nudge the agent or harness what is the purpose of the tool itself. We need to signal the intent of the tool more than describing what the tool does. So for example, here, this one is very simple. I'm just listing all the tables in the database. The input schema comes empty. There's nothing that my tool needs to do this. And then we just return a list of tables. And up here, we have this helper function that is doing that. Let's make sure that it is imported here. And now we can go ahead and give it a try and see how it behaves. So the first thing I will do is start my server. My server is up and running in the port 3000, and now as a harness I will use LM Studio. More than a harness, I will say this is an agent. I don't know. All right. This is LM Studio, and I am using a local model, which I'm going to load right now. Okay, looks like it's done. I'm going to start a new chat, and if I say what tables do we have, and the agent now is going to interact with the LLM and start to figure out what's happening. And it will continue trying to find an answer for me But since we're just testing, I'm just going to stop it and show you how I can now add the MCP server and see how the LLM will pick up on that immediately. I'm going to add my MCP server. I have something else here from another test, but let's go ahead and grab the URL and let's call this one e-commerce MCP. And I think I just need the URL and give it like that. Cool, I think it's working now. We can see that it's showing up here. And as of now, I'm not connected, but once I turn on this toggle, we can see that we have the list tables tool that we created before. Yeah, so now let's say, tell me which tables are available, and immediately picked up the list tables tool and it gave me the tables, which is pretty great. So now if I want to ask, for example, what info is in the orders table, there's nothing that will do something like describing a table for getting more details. And again, the LLM will try its best to try to form an answer, but it's going to just spiral, and that's common to happen. So I'm going to stop it, and spoiler alert, I will create a describe table tool. All right, so I'm just copying, pasting the code here. You can take a look at everything in detail in the repo that I'm going to have linked in the description, but this is what we care most about in this tool. This time the function needs server, the database, and tables. The name of the tool is describe table, and we have the description, and this time we are capturing an input that has to be a string. And this is for the table name. So this tool describes the column and constraints of a table, and that's why it needs the table. If we go to this describe table function, we're doing a couple of things. First, we get the table name. We have a guardrail here. If the table name is not in our tables or doesn't exist, we handle that with an error that the LLM can understand. Otherwise, we use SQLite Pragma to get the table info, and then we create a friendly output for the LLM with all the information from the columns, the types, etc. I'll import my tool, it's added now, and I will restart the server. And if I go to LM Studio and refresh, okay, so now we have describe table available as a tool, and I'm going to just ask again, what's the info in the orders table? And let's see what happens. Yep, and it picks up describe tables right away, and it's going to find out a way to get the information. I'm just going to stop it and say, this time give me the information from the users table, and there it is. It's using describe table again, and we have our outputs. Now, what happens if I ask for a table that doesn't exist, like books? What information is in the books table? It's going to try to find tables again. Since it didn't find it, it's just telling me that there is no books table available in the database. But what if now I want to say, give me the list of users in the users table? This is to try to prompt and get information from the table itself. At this point, we are not exposing that through the MCP server, and we can create a tool that gives our agent the capability to query things from the table. So that's what we're going to do now. New file, new tool, query table. Okay, and this one is a little bit more interesting to see. Again, we have the register tool call. We're going to name this tool query table, and the description is query a table with optional filtering, ordering, and pagination. All conditions are ANDed together, only select queries, no data modifications. In the input schema, we have the table to query, which columns we want to select. If there are no columns specified, it will default to all. We're telling the agent that there is a where as a parameter in the tool. It can be equals, distinct, greater than, less than, etc. And these are going to be the filters and conditions. We have the order by, limit, offset for pagination. And this is the handler that's going to actually do the processing part. So query table takes the database tables and params coming from the tool call. And if you want to see how this query table works, you can just go to the repo. So let's bring this to our register tools, query table, and restart the server. Back to LM Studio, refresh, and there it is, query table. So I am going to do the same question again, but maybe something a little bit more complex. Which user has spent the most in our store? Kind of like open-ended. I would expect the LLM to figure out how to get all this data from the database by using query table. So we can see the thinking here. So it knows that query table doesn't support join or group by or sum directly. So it's going to try to find a different way to do it. So it gave me the user who spent the most, Alice Johnson. And now I can say list the products bought by this user. So there is. Now it gave me all the products bought by the user. Tell me, how did you came up to this conclusion? Be concise. So it says that it identified the top spender, then found the orders of the spender by user ID, then went to find those product IDs from the order items table, and then retrieve the product details and the quantities. Just to be sure, I'm going to open the database in database viewer. If you would run a SQL query to find the user who spent the most, how would it look like? Okay, so I asked for the SQL query that will verify the output for the user who spent the most. So this is the moment of truth. I have this thing called DB browser for SQLite. I already loaded the database. Let's see what happens. If I run it, there it is. Alice Johnson, 26K or whatever, 26,295, and the agent before said, where is it? The same output. So yeah, that worked. With that, now we have our agent connected to a database via MCP Server through an MCP client. We can create as many other tools for the MCP Server. We can be as permissive or restrictive as we need. We can have tools that allow to insert, to update, anything we want, really. So yeah, if you have any questions or you would like me to explore some other aspects of MCP servers, let me know in the comments and I'll see you in the next one.